Hey guys, Daniel here. Hope you guys are doing well. Hope your studies are going well also. Today I'm starting a new series, and it's just gonna be me going through random exam questions. So it's something I've been thinking about doing for a while now, but I've just been so busy. I'm still busy to be honest, but I thought, you know what, I'm just gonna start it. If I start it and I upload it and it goes well, then it will just give me motivation to keep doing them and obviously make the time to actually do them. So it'll be about maybe once a week, maybe more, just depending on how much time I have. And I'll just go through random questions. Um, this one is from an international paper. I was doing this question a couple of weeks ago with my student. I thought this would be a really good question to do. So we're starting off with this one. As well as that, the floor will be open. If you guys have any questions of your own that you want me to do, then yeah, you can just maybe drop me an email or send me the link to any papers, maybe via my Instagram DM or TikTok or wherever. And yeah, I'll be happy to do them in this series. I'll make a playlist for it as well, so it will just be nice, and you can just have I've got all of them. It will be pure, it'll be mechanics, it'll be stats, it'll literally be anything. But yeah, we'll start off with this one. So yeah, parametric question, a bit tricky, especially part C. But yeah, let's get started with the series. Okay, so here's the question. So question 9 says figure 4 shows a sketch of the curve C with parametric equations x equals sec t and y is equal to root 3 tan t plus pi over 3, where t is equal to pi over 6 and pi over 2. T is between, sorry. Part A says find dy dx in terms of t for 3 marks. Okay, so it's not too bad. It's a straightforward part A. So I'm gonna just grab everything I need to do that. So I'll do it here. Okay, so dy dx, right, when you're dealing with parametric equations, just remember this. It's just a chain rule, but I always just do this. Dy dx is equal to dy over dt divided by dx over dt. So just find what both of the derivatives are for x and y, divide them, you're done. So x, right, x is equal to sec t. Sec differentiates to sec tan, doesn't it? So that will be dx dt. So sec t tan t, like that. And then y is equal to root 3 tan t plus pi over 3. Okay, so we've got a composite function here, so I have to use the chain rule. Now, how do you do this? Well, what do you get when you differentiate tan, right? Let me write here. dy over dt. We have that root 3 as well that we can just ignore. So what do we get when we differentiate tan? We get sec squared. So it's going to be sec squared first, and then it's going to be the actual thing inside, t plus pi over 3. And then because of the chain rule, we need to multiply by the derivative of this. So we're going to times by the derivative of t plus pi over 3, which is 1, right? So in this case, it doesn't actually change it, but you still have to know it and apply it. So that way, we can say that dy over dt is equal to just root 3 sec squared t plus pi over 3. Okay, now they didn't ask for any specific format, so literally for the 3 marks, just put one on top of the other, dy dt over dx dt, and then you're done. So I'll do it here. I'm going to just say, so therefore, dy over dx is going to equal, and then I'll get a fraction bar, is going to be root 3 sec squared t plus pi over 3. And the xdt was sec t tan t, wasn't it? Sec t tan t. Now, don't get carried away because we can see a sec and a sec squared here. The arguments are different, so the actual expressions inside the the angles are different, so you can't just cancel. But yeah, literally, that will be it for part A. So part A is done. What is part B telling us? So it says find an equation for the tangent 2c at the point where t equals pi over 3. Give an answer for y equals mx plus c where m and c are constants. Okay, so this again is not too bad. So we're finding an equation of a tangent. Let me just put this there. Okay, so equation of a tangent, I like to use this formula. Y minus y1 is equal to mx minus x1, isn't it? Where obviously you've got a point x1, y1, you've got a gradient you need to find. Now, parametrically, we know that obviously x and y are defined in terms of t. Now we know that t is equal to pi over 3. So what I'm going to do to find out what that x1 and y1 is plug in t equals pi over 3 into my original equations. That will give me the coordinate, right? So where are our equations again? They are here. So let me grab them and we'll just put them in there. So, okay, paste. And then now I'm just going to literally plug in t equals pi over 3 into these. So t is equal to pi over 3. and then I plug it in and see what we get. So sec, remember you don't have that on your calculator. Well, I don't have that on mine anyway. So I'm gonna write it as 1 over cos. So sec of pi over 3 would be 1 over the cosine of pi over 3, wouldn't it? And my calculator is in radians, which is good. So that would be 2, right? So therefore x is equal to 2 when t equals pi over 3. And now this one here, y, what will that be? Let's plug that in. It's going to be root 3 and then tan of pi over 3 was pi. Pi over 3. Okay. Yeah. So yeah. Oh yeah, I thought that. Yeah, that's fine. And then another pi over 3, right? Okay. So that would be -3, right? So we've got the coordinate 2 negative 3. Now we just need to find the gradient, and we can do that by plugging in t equals pi over 3 into our answer in part A. Yep. So let me grab this, and then I'll put this underneath, and we'll plug in pi over 3 into that to see what we get. So this one. Okay, again, you do not have sec on your calculator. So what do you do? Well, what you can do is write this as root 3, and then sec squared is 1 over cos squared, isn't it? So you can write this as 1, I'll times it, 1 over cosine of t plus pi over 3, right? All squared, right? That's the same thing, isn't it? Right? And then over sec t. Or you know what I do? Because I'm gonna write in my calculator, I'll write it like this. So sec is 1 over cos t times by tan t, like that. So I'll just put this into my calculator and see what we get when t equals pi over 3. So all right, when t is equal to pi over 3, what do we get? So plug in all of that in. Well, it's gonna be fraction and then root 3. I'm gonna times by um 1 over, I'll put a square there, and then cosine of t, which is pi over 3. Pi over 3. I know that's 2 pi over 3, but I'm just writing it like that just so it's just super clear. And then plus pi over 3. Pi over 3 like that. And then I'm going to square it, write that. And then now on the bottom, I'm going to write 1 over cosine of the same thing. Pi over 3. Like that. I'm going to times by tan of pi over 3, aren't I? So tan of pi over 3. And close bracket. And let me just double check. Looks fine to me. Yeah, looks fine to me. So click equals now. I get 2, right? So m is equal to 2, right? When we plug in t equals pi over 3. And obviously just put that in your working out as well. So we now have everything we need, right? We've got the coordinate 2 minus 3. We've got the gradient, which was 2. We're just going to plug in that into this equation here. So let me grab this one. I'll grab this one here. And then I'll grab everything that we have, which is this. So now it's easy stuff now. So plug it in everything. It's gonna be y minus y1. So y minus minus 3 is gonna equal the gradient, which is 2, and then x take away x1, which is also 2. So that's y plus 3 is gonna equal 2x minus 4. And then take 3 from both sides. I'm gonna have y is equal to 2x minus 7. And they did want it in the form of y equals mx plus c. So yeah, that's it. That's part B. And then we'll do part C now, the big one. Okay, so part C, the big one. It says show that all points on C satisfy the equation y is equal to ax squared plus b root 3x squared minus 3 over 4 minus 3x squared, where a and b are constants to be found for 5 marks. Okay, so this one here, first thing I'll think to myself when I'm looking at this, if I'm in an exam, well, firstly, curve C was defined parametrically, right? We had X and Y, and they were all in terms of T. Both of them were in terms of T. Now they're saying that this same curve C apparently satisfies an equation whereby there's Y just in terms of X. What's happened to that parameter T? Well, that means we must have to convert from parametric to Cartesian. So it doesn't say explicitly, but it's implied, right? And these are things you need to look out for. Now, second thing as well is I like to define parametric equations in 2 types. So there's the easy ones, or easier, I should say, whereby you've got no trig in it. So for example, let's say, I don't know, let's say x is equal to 1 minus t, for example, and let's say, I don't know, y is equal to 4 over, and let's just say 3 plus t squared, for example, stuff like that. Now, the way you would convert this from parametric to Cartesian is you would rearrange to make t the subject. And let's say in this one x. So let's just say, for example, t would equal, that would be 1 take x. And then now we know what t is, we would plug that into there, right? So therefore, y would equal 4 over 3 plus and then 1 minus x all squared, isn't it? And that would be your answer. Now, this is where you have to rearrange, right? Now, when you're dealing with parametric equations that have trig involved, right, you can't do that. So what you need to rely on is your trigonometric identities, right? They are super, super important, right? That is how you convert from parametric to Cartesian when you're doing these types of questions. So first thing that I look at when I see this, right, is, well, we're trying to find y, right? Now y is equal to that. And the thing that is staring out to me is that I've got a sum here inside the angle, right? So what comes to mind? Well, what is going to come to mind for me is the addition formula for tan, right? So tan A plus B, right? We should know this is in the formula book, I believe, but I can't remember. Tan A plus B is equal to tan A plus tan B, and this is divided by 1 minus tan A tan B. So I'm going to use that. And even if you don't know what to do here, and this looks crazy, this question, right? Just do these things. If you know your identities, well, try it, see what happens, right? So if I apply that, it'll be tan of obviously t plus pi over 3. And then that will equal, and then let me just put this down here. So it's going to be tan t plus tan of pi over 3. And then over, and then it's going to be 1 minus tan t. And then that will be tan of pi over 3, isn't it? Now, what do we have here? Remember, this was y, isn't it? Y was equal to root 3 times that, right? So let's just say, for example, I put y here. We know that y is equal to root 3 times that. So that means I'm going to put a root 3 at the front here, like that, just so I don't forget it. So what I'm going to do now when I look at this as well, fine. I've got tan of pi over 3. We can evaluate that and see what that actually is, right? So if I get my calculator and put that in, tan of pi over 3 is equal to root 3, right? So that way I can say then that y is going to equal root 3 multiplied by tan t plus root 3 over 1 minus, that's root 3, isn't it? So it'll be root 3 tan t. Now, again, I always say this, always have your show that at hand. What is it that I'm actually trying to show? I'm trying to show this here, right? Where I've got y is equal to x squared, ax squared, blah, 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 right? So if I look at this, right, I can see that, well, I've got a root, which is good, right? But I've still got t. I've got tan t's, that needs to go. And as well as that, I've got x's involved, don't I? X squareds. So for me, what that tells me is, well, let me look at this one here, right? Let's look at x equals sec t. What I'm going to do, let me grab both of them, right? There's a couple things actually I would say. So we've used one identity, right? The addition formula. But another thing as well that I always tell my students, right, is when you're looking at a parametric equation, right, and there's trigonometric expressions involved, ask yourself, are there any identities that you know that connects these two? Right? Are there any identities that you know connects these two, sec and tan? Well, there is. It's one of the Pythagorean identities, isn't it? So what is that one? That's going to be 1 plus tan squared, t in this case, is going to equal sec squared t. Remember, you just divide sine squared plus cos squared is 1 by cos squared, and you get that, right? So this one connects them. So I'm going to try and use this here. Okay, now, how does that work? Well, we know what x is. X is sec t, right? Which means that x squared is going to be sec squared t. So I have an expression for sec squared t, right? It's x squared. I can replace that here, can't I? So that means I can say, well, 1 plus tan squared t is going to equal x squared, right? Now remember, look at what look at where we are at, right? We have tan t's. We don't want tans anymore. We want to try and get in terms of x, right? So that tells me that I'm going to rearrange to make tan t the subject from here, isn't it? That way I could put this into there. Let me actually crop this, or let me grab this so I don't need to keep going up and down and see what happens. So let me put this here. And then what I'm going to do is I'm going to rearrange, right? So I'm going to rearrange this one. So it becomes x squared take 1 is going to equal or you know what, I'll do it on the other side. I'll swap it over just so it just looks nicer. So I'd say tan squared t is going to equal x squared take 1. And that means that tan t is going to equal the square root of x squared minus 1. Now remember, this is an equation there. Don't forget your plus or minus, but just to be on the safe side, well, which one are we going to pick, right? Well, we're square rooting tan t. Let's go back to the parametric equation, right? We've got this here. We can see that tan, or t, sorry, was defined between pi over 6 and pi over 2, right? That's in the first quadrant. And all trigonometric expressions are positive in the first quadrant. So I'm going to say that tan t is greater than 0, right, on that interval. So that means that when I square root and I get plus or minus, I know for sure that I can take the positive solution, right? So that's just something to be aware of, right? So with that being said, I know that it's going to be the positive one. So I'm going to rub that out like that. And I'll rub this out as well because it's still positive. So I now have an expression for tan in terms of x. I can plug that into there. So that means I'll have y is equal to root 3 times by, and then it's going to be x squared minus 1 plus root 3 over 1 minus root 3 and then root x squared minus 1, like that. So we are here. Now let's see the show that again. Always have this at hand. Okay, this is very promising because now we've got x squares, we've got root 3s and so on and so forth. So what do I need to do? Well, firstly, what I can do is if I look at the denominator, right, I can see that I've got this here. Now, this is a root times another root. Remember your third laws. Root A times root B, right, is equal to root A times B. So that tells me that I can actually combine those. So root 3 times root x squared minus 1, right? This is going to equal all under one root, 3 and then x squared minus 1, isn't it? And then we can expand that and we get 3x squared take away 3. And that's very good because we have that expression and I'll show that. It's not at the bottom, but it's very good progress. So that's fine. As well as that though, this root 3 that was on the outside, we can actually expand it in, can't we? So I'll do like that. So when I do that, let me just zoom out a bit. Y is going to equal, it's going to be that times by that, right? Which we know is actually equal to this, isn't it? So I can actually just put it in straight away. So let me get a fraction bar, a nice one. It's going to be root 3x squared, take 3. And then root 3 times root 3 is just going to be 3, isn't it? So I get that there. And then on the denominator, it's going to be 1 minus, and then this expression here, isn't it? Root of 3x squared, take 3. Okay, so we're here now. Now, that's to show that we do not have a root on the denominator. Well, what must have happened? Well, we need to rationalize, right? So what I'm going to do, and obviously the concept is still the same, but the expression is a bit different, isn't it? Right? Because it's algebraic. So if I rationalize, it's going to be 1 plus the square root of 3x squared, take 3, and then 1 plus that, isn't it? Like that. Okay, so now I need to just tidy this up and see what I get. So let's do the numerator first, the harder part. So if I do that there, like that, and then like that, and then like that, it's going to be that times by that, which is just going to be root of 3x squared minus 3. So put that there. Root 3x squared minus 3, and then it's going to be that and that, which is going to mean that the square roots are going to cancel. It's just going to be plus, and it's just going to be 3x squared minus 3. And then this one is going to be 3 times 1, which is a 3, like that. And then as well as that, 3 times the square root of all of that, that's just going to be plus a 3, and then it's going to be root of 3x squared minus 3. So that is the numerator expanding out. Now, yeah, let's tidy it up and then we'll do the denominator, won't we? So if I tidy that up here, I'll do it here. We just draw another fraction line like that. What do we have here? Well, firstly, I've got a minus 3 and I've got a plus 3. Those are going to cancel, aren't they? So that's going to cancel. As well as that, what do I have? Well, I've got root 3x squared minus 3, and then I've got 3 lots of roots root 3 lots of root 3x squared minus 3. So altogether, that's going to be 4 lots of it, isn't it? Because there's a 1 there, right? 1 plus 3 is 4. So I'm going to have 4 lots of it. And let's look at to show that. Where was it? They want it there. So that's good. So there, that's good. Because that means I'm going to have plus, whoops, not that one. I'm going to have plus, it's going to be 4 lots, right, of root 3x squared minus 3. And then what's left is that 3x squared term, which will go there, like that. And that numerator is perfect, isn't it? So all we need to do now is just show that we get 4 minus 3x squared on the denominator by just doing this here. Now this one is even easier, right? So um, times those together. Now whenever you're rationalizing, right, the middle terms are always going to cancel, aren't they? So 1 times 1 will give me a 1, like that. And then I don't need to do 1 times positive of that and then minus that times that because they're going to cancel. So it's just going to be 1 minus, and then I will times these two together, aren't I? These two right here. And that's just the same thing, right? So the square roots are going to cancel. So it's going to be 1 minus, and I put this in the bracket now because we're taking away, 3x squared take 3. Right? And then now expanding that, that's just going to be 1 minus 3x squared and then plus 3, isn't it? Because of the two negatives. And that way we can say then that y, right, is going to equal 3x squared plus 4 and then 3x squared take 3 all over 1 plus 3 is 4. Take away 3x squared. And that's exactly what they wanted, isn't it? Perfect. So imagine you're in an exam, you get this show that and you get that. That is a nice 5 marks. And yeah, that's pretty much it. So yeah, thought to do this question because it was a bit of a tricky one. But yeah, that's it. Done. Hey guys, hope you guys are doing well. So yeah, that's the question. Hopefully you found it helpful. I definitely thought it was one of the trickier parametric Cartesian questions that I've seen, which is why I wanted to do it. And yeah, I just remember now actually, I'm sure that I can maybe host like maybe like a Google Dropbox where you guys can just send me questions there and I can just pick them. I'm just thinking of how I can make life easier for you guys. But I'm actually not sure what it is I'm talking about. So if you guys know what I'm talking about, then yeah, then let me know in the comments. But yeah, this is question 1 of the series. So hopefully you found it helpful. And yeah, if you did, then always it will be much appreciated if you like, comment, and subscribe and share with your friends. And yeah, that's pretty much it. Keep studying hard. You guys got this. I know you guys are all gonna smash it in June. And yeah, keep doing what you're doing. Take care.